proportion I can write down.
Like the sides or just the numbers?
Let's start with just naming the sides, and then we'll put in the values.
Okay. Wait. I don't know which. I'm gonna say BC over DE.
Mm-hmm.
AC over FE, and then AB over F.
Good. So you did large over small. Okay. So those are my three like ratios that are going to be proportional to each other. And now I can pretty much pick two out of the three, set up a proportion, fill in the blanks, and go from there. So let's just start with this one right here. All right. So if I go with this one, what numbers am I putting in there?
3x plus 8 over 5
Mm-hmm.
is equal to 28 over y plus 5.
Okay. So someone let me know, is this a good proportion to set up, or should I use two different values?
No, I don't think it is, because then we're gonna have to deal with both variables at the same time. So
Right. This one has x's and y's. So maybe AC over FE isn't the best one to use. Maybe we can use AB and FD. Let's see. So it's that one. So this gives me what? 12 over
12/3.
Yeah, that's a much better one because now I only have x. There's no y involved in this proportion. So it's a lot easier. So let's go ahead and solve it. Cross multiply and go from there. So this is going to give me 3 times 3x plus 8 equals 60. Now go from there, solve that equation, solve for x, and then we will see what we all get. I'm going to move this over for, where do I have more room? Right here? That's better. Okay, go ahead and solve it. Take about a minute.
Miss, I got an answer.
Okay, give everybody else a moment to finish. All right, solving for x, what do I do first? Let's go run through this real quick.
Distribute, so it'll be 9x plus 24 equals 60.
Then?
We subtract 24,
Mm-hmm.
we get 36, and then that will give us 4.
Good. X equals 4. Awesome. All right, and then now we got to set up a proportion to solve for y. So similarly, I'm going to go ahead and find two pairs where one of them has the variable and one does not. So I'll start with FE over AC. And then what's the other pair that will work for us? FD, good, over AB. So here that's going to be Y plus 5 over 28 equals 3 over 12. And then same thing, we're just going to cross multiply and solve it. So this is 12 times y plus 5 equals 3 times 28. 3 times 28, what's that?
84.
84. All right, go ahead and take a moment to solve that one. I sound sad. I'm just really tired. I'm not sad, I'm just tired. Rios, that's a good question. That happens to me because when I'm tired, my face shows it, and every time I look, I am tired. People ask me if I'm sad. It happens all the time. You got to. Okay. So same idea. We distribute. We get 12y plus 60 equals 84. Subtract 60 from both sides. That gives me 12y equals 24. Divide both sides by 12. I get y equals 2. So those are my answers. Y equals 2 and x equals 4. Any questions, comments, concerns, confusions, anything at all? Okay, what's your concern? Good question. Today's the 10th. I believe that not tomorrow, but Friday. Because if I remember correctly, the email said until the 11th. Let me double check. I'll double check right now. No, this is not for virtual students. This is just for the ones who are on quarantine right now. Okay, here's the email. Oh, okay, no. You were right. It is tomorrow. It is tomorrow. Yeah. So today is your last day of quarantine. Tomorrow you go back. Okay. Any other questions? Alrighty. So today we are going to be going over something called the triangle proportionality theorem. So can I have a volunteer? Let's just begin by reading the theorem, and then we will talk about what it actually means. Who would like to volunteer? Guys, let's just
A
somebody read.
line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally.
Okay. So here's an example of what that means. So there's a line that has to be parallel to one of the sides of the triangle. So in our example over here, here's a line that's parallel to the base. So these two are parallel. And what it does is it creates a proportion. And let's take a look at what that proportion is. So this is telling me that because I have this parallel line, AE over EB is equal to AF over FC. Okay. So EA over EB is equal to AF over FC. So let's think about how that's similar to what we've already learned about triangles. So what we've talked about before, if you had two similar triangles, like in this example, what would be the proportion that we would come up with before we learned about this theorem?
Probably we would have done like the bigger side over the smaller side or the other way around.
Right. So we would have done something like, let's say we did AE. If I did AE, what would be the bottom? What would be the denominator?
AB.
Over AB, right? We would have gone small to big and then AF over AC, right? So before today, what we've been doing, like we did in this example too, what we've been doing is small over big. You take the small triangle and the big triangle. Well, what we're kind of learning today is a little bit of a shortcut because you can also make a proportion using, rather than splitting it up into two whole triangles, you can just do the small segment over the bigger segment and then smaller segment over bigger segment. This is the way that they did in this example. So we're going to kind of like see why that works in just a moment, but for now, go ahead and just make sure that you have the theorem. You might as well just copy down the way you see it on the screen. So go ahead and take about 3 minutes to do that. All right, so finish writing this down, and as you finish, let's think about what I wrote down here. A little bit of a side note. How do you know that triangle ABC is similar to triangle AEF? Because we are kind of assuming that. So how do we know?
Because we know that they have two congruent angles because of their corresponding angles. Yeah, I think that's what it's called. There's
Good.
the corresponding angle, and then they both share a.
You got it. So it all comes down to the AA similarity theorem, and which angles in particular are we talking about? So which ones are congruent? So angle A, yeah, angle A is congruent to itself. That's reflexive. And then well, you guys are giving me side lengths. I need an angle. So I need three, give me three letters. AEF is congruent to A or EBC. Good. And how do we know that? Oops.
Because there is a transversal and the little parallel line makes them corresponding angles.
Good. So we have a transversal, and so those two are corresponding angles. And just with that, we have enough information to have a similarity. Okay, cool. So now let's take a look at an example. Let's understand why this works. So I have this triangle. Do I have two similar triangles?
Yes.
I do. Triangle ABC is similar to triangle AXY. Now let's actually take a look at the way we did this before. I say before, but like the way we usually do this. Usually we would, let's name this, the missing side, let's call it M. And let's set up a proportion just the way that we usually are used to doing it. So who can give me one proportion that I could set up? Nine over 13 is equal to?
Can we use the other side?
Mm-hmm.
Oh, okay. So it would be 10 over 10 plus m.
Good. 10 over 10 plus m. Okay, so all we did was ax over ab is equal to ay over ac. So there's our proportion. Let's go ahead and solve it. Let's just see what happens. We cross multiply. We get 9 times 10 plus m is equal to 130. Now we go ahead and distribute. Get 90 plus 9m equals 130. What do I do here?
Subtract 90.
Mm-hmm. Good, subtract 90. What's 130 minus 90?
20.
40.
Wait, 40.
Where did y'all say 20? And
40.
Tyrone just went and copied his answer like.
And then we divide by 9. We got 40 over 9. Can I simplify that at all?
Into a whole number or a decimal?
Into a simpler fraction.
Oh, let me think about it real quick.
Think about it.
It's only 3 times 3, right? 3 times 3. But 40 can't. Oh, 15. Yeah, okay, never mind. By 3, yeah.
Did you just say 15?
15.
That's 45.
At 45.
So no, you can't. The answer is no, but you can just leave it as 40 over 9. Okay. So this is how we usually did it. Now let's use our triangle proportionality theorem instead. So this time I can just, instead of thinking small triangle and big triangle, I'm going to use just the segments. So let me kind of color code this. So on one side, I have AX over BX. And on the other side, I have AY over CY. Okay. So instead of doing like the small over like the whole length, we're doing just the one half of the segment over the other half of the segment on both sides. So what's this going to be? This will be 9 over x, and then not x, 9 over 4, sorry, and then 10 over m. So far, so good. Any questions on that? Okay. Well, we're still going to follow the same steps. I'm just going to distribute. And we get 9m equals 40. Well, all I got to do is divide by 9, right? And we get the same exact answer.
You get 4.4443,000.
40 over 9. So let's actually like kind of see what happened. What step was I able to skip completely?
The whole like solving algebraically and distributing, like we just got like the end result basically. We didn't have to like do the whole equation.
Yeah, this whole entire section we basically did not need to do. It was like extra work almost. So the triangle proportionality theorem is actually super useful because it allows us to get our answers much more quickly and much more easily. It's like a little shortcut. So it's actually really, really nice. It's very useful. Any questions on why it works or anything like that? Okay. Well, unfortunately for you, we also need to go over how to do that. What we just did, what I just proved that you end up with the same answer. But now I'm going to show it to you algebraically because you have to kind of, this might come up on a test. I don't know if it will, but it's important to just kind of see algebraically why this works. So I'm going to stick with the same exact problem, but instead of using all of the numbers that are in there, I'm just going to keep using just the names of each segment. Okay, so what I'm going to do first is going to just be, I'm going to set up my proportion using similar triangles. So the way that we used to do it all the time. So the first, like the before. So what we usually did was AX over AB. Actually, I'm going to do big over small. So AB over AX equals AC over AY. Right? Just keeping it, I'm not using the numbers, I'm just going to be using the names of each segment. But we know that AB, so AB, this whole section, is really two sections put together, right? AB is really AX plus BX. Do we agree with that? We agree, right? So I'm going to kind of rewrite it. So AX plus BX over AX. And you can say the same thing about AC. AC is really just AY plus CY. Right? It's just, it gets split up if you split it up into its two components. So I'm going to rewrite that one. AY plus CY over AY. Agree? So far, nothing too crazy, right? Any questions so far? Okay. Well, the way fractions work, remember, let me just do a little sidebar. You do not need to write this part down. But let's say I'm adding two fractions. So let's say I'm adding like 3/4 plus 2/4. What's 3/4 plus 2/4?
5/4.
5/4. So what did you do? You just added the numerators, only the numerators. So what Perla did was 3 plus 2 over 4, which gave her 5/4. So when you add fractions, you're only adding the numerators, right? So what we can do is we can take something that looks like this and split it up into something that looks like that. We can kind of split it up. If I have 3 plus 2 over 4, that's the same as 3 over 4 plus 2 over 4. So I'm going to do that with my fractions. Let me move this. I'm going to keep this on the screen so you can see it. Just moving it down a little bit. So this is the same as ax over ax plus bx over ax. See, I just kind of split that fraction into 2. And I can do the same thing on the other side. Ay over ay. Oops, not equals, plus cy over ay. So does anybody have any questions on how I split that fraction up? Okay. Well, now look at what we've got. We have ax over ax and we have ay over ay. What happens when you have the same numerator and denominator? What does that simplify to? Good, Tyrone. To 1, yeah. So like 3 over 3, 4 over 4, whatever that is just going to equal 1. So I have 1 plus bx over ax equals 1 plus cy over ay. Well, I have a 1 on both sides, right? And algebraically, what I can do, I'm allowed to do this, I can subtract that 1. But I just have to make sure I do it from both sides. Well, what happens when I subtract that 1?
You're left with bx over ax and cy over ay.
Right, because the 1's basically cancel out. So the 1's go away, and I'm left with, let me highlight with the right colors, bx over ax equals cy over ay. And that is the triangle proportionality theorem. And that proves what I already showed you that makes sense using numbers, but I was also able to prove it using algebra, just pure algebra, no numbers. So it shows us that at the end of the day, you can just use the two segments, the shorter segment with the longer segment on both sides. So does any of that still, any confusions, any questions on how I got any of those numbers?
Miss, what you just did is so overly complicated.
Well, that's kind of what algebra does. It looks complicated because it's all these letters, right? Like that is complicated. You're not wrong. However, recognizing the patterns and understanding why you're able to do what you did is more important. So even though it looks complicated, each step of the way had a very logical, progression. Like we did things that made sense. We didn't do anything crazy. It's just, it looks a little confusing. Any other questions? Okay. Well, now that we know the theory behind it, remember, it's actually pretty easy when you have numbers. So go ahead and take a look at these examples. And for each of them, you're going to find the missing side. So for number 5, you're finding DG. Let's just call these M, and I'll call RN. I'll also call it M. So just go ahead and set up your proportions using the triangle proportionality theorem and see what you get for M on both of these triangles. Take about 2 minutes, 3 minutes. Should not be very long because these numbers are going to be a lot easier. Okay, about 30 seconds. Alrighty, time is up. So number 5, what proportion can I set up here? So we've got 24 over 32 is equal to M over 40. Exactly. Now you could have done it the opposite way. You could have done 32 over 24 equals 40 over M. So whether you did it short over long or long over short, both ways will work perfectly. I'm just going to do it the way Perla said it. And let's see what we get. So 32 times m, got 32m, equals 40 times 24. What do you get for that? Forty times 24. 960. Divide both sides by 32. We get m equals 30. Perfect. Anybody have any questions on number 6? Or 5, I mean? All right. So number 6, very similar. What's a proportion that I can set up here? For number 6. Okay, Perla. So somebody else, go ahead and let us know. What is a proportion? There's more than one answer, but what's one way I could write it down? All right, so mq over qp, so 8 over 5 equals 10 over m. Good. Or the other way around, 10 over m equals 8 over 5. Same exact answer, no matter which way you do it. We got 8m equals 50. I got to divide both sides by 8. 50 divided by 8. Can I simplify that? So as a decimal, I get 6.25, but if I keep it as a fraction, what can I simplify that as? Yeah, by 2, so 25 over 4, which equals 6.25. All right, cool. Questions? How do you feel? It's not too bad, right? It's pretty simple. It's a nice shortcut to have. It's a nice thing to know because now you actually make your life a whole lot easier when you're solving these types of problems. But do we have any questions on these two? All right. We got a proof. Of course we got a proof. What else would we be doing in this class if it wasn't for proofs? No, actually we kind of did this already. So I think I might skip the proof because we did do it. We did it. We didn't know it was a proof, but we did a proof on this slide. We did an algebraic proof. We used algebra to show that the triangle proportionality theorem works. You just didn't know it. I got you. Okay. Well, whenever there's a theorem, a lot of times you're going to have the converse of that theorem. So can I get a volunteer to read the converse of the triangle proportionality theorem?
If a line divides two sides of a triangle proportionally, then it is parallel to the third side.
Good. So if you know that the sides are proportional, then you can conclude that the two lines are parallel to each other. So remember, it's the opposite of what we looked at before. This was telling us if the sides are parallel, then it is proportional. This one's saying if it is proportional, then the lines are parallel. So it kind of takes the statement and you can go say it backwards. So go ahead and take about a minute or two to just write this converse theorem down in your notebook.
Ms. Lopez,
Mm-hmm.
in this case,
Mm-hmm.
would they tell you that they're proportional, and then you'll be like, oh, the lines are parallel? because
Yeah.
they tell us that.
Right. It would be either, let's say you have, I'll show you an example. I'll show you two examples actually. So keep writing the definition and I'll write these examples down. So take a look at these two examples. In example A, what are they already telling you?
That the lines are parallel.
They tell you that the lines are parallel, so you can conclude, because they're parallel, you know that. So this leads to, let's call this x, let's call that y. So this leads to, now you know that ax over xb is equal to cy over yb. Like you can make that conclusion because they are parallel. In B, it's not telling us anything about them being parallel, but what do we notice? What do you notice about example B? What sort of relationships?
That basically the smaller portions are being like, actually, I don't know, they're just proportional. Like
They're proportional, yeah. Yeah. 4 over 2 is equal to 6 over 3 because 2 equals 2. So they are proportional. And since they're proportional, now I can say, oh, okay, xy is parallel to AC. So whatever you're given, you can come to a conclusion. If you can conclude that they're proportional, if that shows you that they're parallel lines, then you're using the triangle proportionality theorem. If it's showing you that there's proportional sides, then you're using the converse of the triangle proportionality theorem. So this one's the converse. So it just depends on what you have in front of you. So for example, here's one where we don't know if those lines are parallel, so we need to figure out if they are. We want to know, is MN parallel to KL? Let's figure it out. In order for them to be parallel, what has to be true about the side lengths?
They have to be proportional.
Good. If this is true, then that would mean that 42 over 21 must be equal to 30 over 15. Now, is that a true statement? What is 42 divided by 21? 2. And what's 30 divided by 15? Also 2. So this is true. So therefore, MN is in fact parallel to KL. And because of this, what else is true? We also know that the two triangles are what? Are they congruent?
They're similar.
They're similar. All right. So that's basically how it works. So how about this one? Verify, so ask yourself, are they parallel? Is DE parallel to AB? So take a moment, and they give you the missing side lengths. Take a moment and see whether or not this is a true statement. So Perla says she's agreeing and disagreeing with herself. Me too, like most of the time. Okay, so let's check this out. So they're telling us that AC is 36. So should I put a 36 right here? No. AC is 36, so the whole thing is 36. So how long is AD? Good. So AD is 16. What about BE? And BE is 12. So let's check this out. Let's check the proportion. 20 over 16, and then 15 over 12. How do I simplify? And we're trying to see if these two are equal. How do I simplify 20 over 16? Don't use a calculator, just simplify it as a fraction.
5 over 4.
5 over 4.
Yay, I did that in my brain.
And then what about 15 over 12? How do I simplify that one?
5 over 4.
Also 5 over 4. When you divide by 3. I think Jalen was telling us what to divide it by. Yeah. So when I divide the top and the bottom by 3, I get 5 over 4 on both sides. So therefore, we know that DE is parallel to AB. Okay. So that's it. Again, the math that we're doing is not very difficult. Today's class is definitely a little bit more simple than what we've been working on. Any questions on this problem? Cool. All right, let's reflect a little bit. A student states that UV must be parallel to ST. Do you agree? So take a moment. There's no numbers, but we do know a few things about these two triangles. So take a moment, think about it. And I'd love to hear, you can type your answers in the chat, or when we think about it for a little bit and I tell you guys to come back, we can discuss this out loud. All right. So let's think about it. We don't know any numbers. We don't have any values. So like we've been doing here, we've been verifying it using the numbers. But since I don't have any numbers, what else can I rely on? How can I try to prove that this is true?
To prove that we have to prove that the sides are proportional.
So we have to prove that the sides are proportional. Now I don't have numbers, but what do I have?
Lines telling us that they are congruent.
Good, we have congruent markings. So we know that SU is congruent to RU or UR. We also know that RV is congruent to VT. So when you set up a proportion, we know that these values are equal to each other, right? So UR over, or if I do SU over UR, since they're equal to one another, what does that equal?
VT over VR.
So yeah, so when I write it as a proportion, yes, VT over VR.
Oh, you meant like 1?
Right, so what I'm trying to get at is that this equals 1 because those are equal values. You can rewrite this as SU over SU and VT over VT since those segments are equal to each other. And this is 1 and that is 1. So we can show that the side lengths are proportional. Is there another way to prove this though? Because that is one way to prove it, but there is one more
Maybe the angles?
argument. The angles? Did you say angles?
Yeah.
Yeah. So given what we see in this figure, which angle do we know is congruent? R, right? We know that R is congruent to itself because it's reflexive, right? Well, now that I have the reflexive angle in there, do I have any triangle similarity theorems? Can I prove anything? Remember, there's the AA similarity theorem, there's SAS similarity theorem, and there's one more, SSS. Do I have any of those? Which one?
SAS.
Well, you do have SAS. So because of SAS, I know that triangle RUV is similar to triangle RST. That's because of SAS. And what is true about similar triangles? What would be congruent in similar triangles?
It's like their angles.
They're angles, right? So therefore, angle RUV is congruent to angle RST, and on the other side, angle RVU is congruent to angle RTS. And that just comes from the definition of similarity. right? And then finally, what do we know about the relationship if these are congruent? And you can think about this as transversals. What type of angles, by definition, are they to each other? So what kind of angles are they? What's their relationship? How do, okay, that's what I was gonna, yes, corresponding angles, right? RUV and RST are corresponding angles, and then RVU and RTS are also corresponding angles. And because of that, I can say that UV is parallel to ST. I just used the converse of the triangle of the corresponding angle theorem. So kind of like a different way to do it, but we basically are able to prove the same thing using two different methods. On the one hand, we can just use the proportions and prove that they are proportional, and then therefore they have to be parallel because of the converse of the triangle proportionality theorem. So what we just talked about. But on the other hand, we actually could have done it a different way using knowledge from before. So using prior knowledge, we could have done it as well. But both ways we can figure out that yes, these two are going to be parallel to each other. Okay, a couple practice problems. We're almost there, almost done. Go ahead and I'll read this out loud. I want you guys to work on it on your own. So on the map, 1st Street and 2nd Street are parallel. What is the distance from City Hall to 2nd Street along Cedar Road? So we're looking for this distance right here. So take a moment, 2 minutes on the clock, go ahead. See if you can figure this one out. All right, time is almost up. So what do we got? What is our proportion going to be?
I got a bunch of decimals when I did mine.
You got what?
Well, they're all decimals. Never mind. I got decimals, but obviously I did.
Yeah, they're all decimals.
I did x over 2.4 equals to 2.1 over 2.8.
Good. That is correct. So this is kind of like if you wrote this as a triangle. It's just another similar example. So 2.1, 2.8, then that's x, and that's 2.4. cross multiply and set up that proportion. What do we get? We get, what's 2.1 times 2.4? 5.04. So I end up with 2.8x equals 5.04. Divide both sides by 2.8. What do we end up with? 1.8. Very good. Questions on this one? Not too bad, not too bad. Okay, moving right along. Let's kick it up a little bit. You know, always try to make it a little bit more interesting, but let's do this one together. So for which value of x would GF be parallel to HG? So they're basically asking us, okay, if these are parallel, let's see what makes sense. Let's go ahead and set up a proportion. What can I write into my proportion?
We can do 5x plus 1
Mm-hmm.
over 45, and then Janelisa has the other side.
Good. You got it. Nice. So there's our two sides of the proportion. Yeah, you were telepathically teaming up. And I know we've got a lot going on, but we can still work with this as we usually do. So this is going to be 40 times 5x plus 1, and then 45 times 4x plus 4. Challenge yourself, do it on your own. Algebra all alone, you got this. Solve that equation. We'll see what we get.
Miss, I got 7.
All right, so let's check it out. So 40 times 5? 40 times 5 is 200, so 200x plus 40. What's 45 times 4? 180 equals 180x and 180. Good. All right. Well, now I need to solve this. So I have x's on both sides. What should I do? Minus 180x. Good. $200 minus 180? 20. Good. Nice, Rios. 20x plus 40 equals 180. Now what? Good, minus 40. What's 180 minus 40? 140. What's 140 divided by 20? We get 7. X equals 7. So a little bit of algebra throwback, but at this point, I mean, this is something that everybody here should feel 100% comfortable solving, no issues at all. Questions on this one? If you don't, you're not practicing enough. But at this point, this is easy. This is like, you could do this in your sleep. Okay, next up. Now we got some slightly more wordy problems, but let's just see if we can come up with our answer nice and easy. Is line BC parallel to line DE? Choose the best justification. So go ahead and just read the answers to yourself. Remember, these are a little bit more wordy, but we're still working with the same type of problem. So we're still working with that triangle proportionality theorem. Take a moment, read through the answer choices, make a selection, and then we'll go through the answers. All right. So first things first, let's figure out, are they parallel? Is DE parallel to BC? What proportion can I set up to check my answer?
5 over 15
Mm-hmm.
is equal to 6 over 12.
Good. So the trick here was the whole thing was 20, and if the whole thing is 20, then the AE has to be 5. Okay, 5 over 15 equals 6 over 12. 5 over 15, what do I simplify that as?
1/3.
1/3. How about 6 over 12? 1/2. Uh-oh. Do they match? No, they do not. So therefore, DE is not parallel to BC. So that's it. That's our answer. So that's what it looks like. Sometimes it might not be parallel. So you always have to check, always got to make sure that those two answers are proportional or not. Okay, I think I have just one more. Here we go. Segment AB is parallel to segment AB prime. Sorry, segment AB prime is parallel to segment AB. Part A, what is the length of A prime A? So A prime A, right here, that whole segment. Who would like to set up a proportion for us? Anyone? Okay, so 12 over x is equal to 8 over 20. Good. Good. You got it. So let's go ahead and cross multiply. So we end up with, Perla's going back into her hole. 12 times 20, 240. And 240 divided by 8. $240 divided by 8 is 30. Good. So A prime is 30. How about B prime? What proportion can I set up here? Anybody going once? Going twice. 6 over x equals 12 over 30. Oops, 12 over 30. Okay, cool. Cross multiply, I get 6 times 30. 180. 180 divided by 12 is 15. So blue BB prime is 15. All right, you guys, that is all we are up to today. So at this time, class is over. I actually have not assigned homework because at this point, the Khan Academy, like the way that they do it on Khan Academy is not really the same as the way they do it for the tests you guys take. So I didn't really want to give it to you because it would actually make it more confusing. So this week, basically no homework, but remember that there will be a quiz on Friday. So anything you learn during class will be on that quiz. So that doesn't mean that, you know, you don't have anything to do, because you could just spend a little bit of time studying each day so that you're ready for your quiz on Friday. So good job today, guys. We are ending a little bit early, which is good because Miss Lopez needs to fill up her coffee cup a little bit more. But I will see you guys all tomorrow.